Hello and welcome to Math Lessons with Linda. Today's topic is another conic section called hyperbolas, and here is our first example. The first thing you should notice, a big difference between circles and ellipses, is that in a hyperbola, the sign between the two fractions is now subtraction. And that's your big clue when you're looking at an equation that you do have a hyperbola. So here's our equation, y plus 2 squared all over 4 minus x minus 1 squared over 16 equals to 1. So just like an ellipse, before you begin your problem, you do want to have it equaling to 1. So the first thing I'm going to pick out is the center, and I find the center the same way that I have on the other conic sections. I have my XY point and I take the opposite of what is inside the parentheses for the values. So I get a positive 1 and a negative 2 for the center. Now, the other thing that is different with hyperbolas from ellipses is that in a hyperbola, we have what's called a transverse axis. And the transverse axis is going to be the orientation in which your hyperbola opens. And in a hyperbola, the transverse axis is always the one that is first in the problem. So in this problem, I have the y variable in the first fraction. So my transverse axis is the y-axis. And so what that tells me is that my hyperbola is going to open both up and down. So that's another difference. A hyperbola looks like it is actually two separate parabolas that are opening, and they are opening in an opposite direction from each other in relationship to that y-axis. So that's the transverse axis. The other axis is called the conjugate axis, and that's the axis that comes second. So in this case, it would be the y. And I still do need these values that go with the transverse and the conjugate axis so that I can figure out how wide and where to position my hyperbola, which we'll get to in just a moment once we find a few other values. So in my transverse axis, the a squared is always going to be first, and the b squared is always going to be second. Remember, in an ellipse, the a squared kind of moves around. But here the a squared and the b squared are fixed. So that means that the transverse axis goes with this a squared equaling 4. And so that means my a value is 2. And that's going to be the distance from my center to a vertex for each of these parts of my hyperbola. The conjugate axis, the x, is the b squared equals 16. And so b is 4, and that's just going to tell me how far I need to go to make like the width of my hyperbola. So we have enough right now. Let's go ahead and start sketching some of this, and then we'll go back to finding some other values that are important that we will also need. So I'm going to make, since my center is at 1, -2, I'm going to make my graph just a little bit skewed so that I have more room over here to put in my center. If you have graph paper, that's always a little bit easier to keep things organized. So I've got 1, -2, here's my center. Now my transverse axis, remember, is the y, and so this is going to tell me I need to go 2 spaces up from my center and 2 spaces down from my center. So we can make this the plus minus. So I'm going to have one vertex right here. I'm going to go down 2 spaces. I'm going to have another vertex right here. I'm going to use the 4 to go left and right. That's my conjugate. 1, 2, 3, 4. And then from here, 1, 2, 3, we'll make one more out here. Now these are not actually vertices, but this is what we're going to do. It'll make sense in just a moment, so hang on with me. I'm going to create a box that I use to go through these 4 points. And what this is going to do is help me with figuring out how wide I need to make my hyperbola or how narrow I need to make my hyperbola. So let's pause for just a moment. There's one other thing that we still need to find that's going to go inside here, and that would be the two foci. And the foci, remember, are the points that are going to be like inside of this, and there's going to be two of them, and they are going to be on the transverse axis. So to find the foci for a hyperbola, we actually use a formula that looks very familiar. This looks exactly like the Pythagorean theorem. So that's something that maybe is a little bit easier to remember this time. So I'm going to substitute in values for the a squared and the b squared. So I have 4 and 16 for those. C squared is 20. So C is the square root of 20, which, since we're going to sketch this, it would probably be nice to have that value. So we are going to figure out the square root of 20, which is about 4.47. So just a little bit shy of 4.5. So what I'm going to do now is I'm going to put the C value also on my graph. And so what happens here is I'm going to start at the center. I'm going to go up 4 and at 4.5 almost, and I'm going to go down almost 4.5. So 1, 2, 3, 4.5. There's one foci. And then I have to do the same thing from here down my 2, 3, 4. I'll extend this a little bit so I can get this other one here. Now, we have found all of the parts that we need, except for one new part that is not something that we do in a circle or an ellipse. So remember, we had made this kind of dotted outline. So what I'm going to do now is I'm going to draw what are my asymptotes. And they're going to go from corner to corner and through my center. So I'm going to make these dotted lines this way, and then I'm going to make another dotted line this way. So these asymptotes are guidelines to help you figure out the width of your hyperbola. So I'm going to start here at my vertex, and I'm going to sketch out my graph so that it gets really, really close to these asymptotes but doesn't touch it. So I've got my top part. I'm going to come down here and do the same thing and sketch it, and I'm going to get the bottom part. And you can tell that these foci are right inside these two parts of my hyperbola. Now, you may also be asked to find the equation of these asymptotes. Okay, so on a hyperbola where you have the y being the transverse, the equation for your asymptotes looks like this. Y equals plus or minus, because these are just lines, it's going to be a over b x minus h plus k. Now this looks terrible, but we know what all of these values are. So I'm just going to plug those in. Plus or minus, my a was 2, my b was 4, my h is from my center, and my k is from the center. So really what we're most interested in is this slope really true to what my graph is? So 2 over 4. So up 2 over 4 gets me to this corner, right? And for the other direction, I would go up to -4. So I feel pretty confident that I have my asymptotes correct and that I have my equation of these asymptotes correct. And so that completes everything that we would need to have for our hyperbola, including the foci and doing our sketch. And that's a really good example of how to solve and graph a hyperbola.